Hey guys, Mr. Backerer here. In this video, we're going to look at algebraic models. So an algebraic model uses formulas to relate different variable quantities associated with whatever phenomena it is that's being studied. And the big benefit of an algebraic model over a numerical model is that we can use our formula to help us predict some unknown values. So in this example, we're looking at some pizzas. Okay, we've got a pizzeria, and they're selling a rectangular pizza that is 18 inches by 24 inches, and that sells for the same price as a large round pizza, which it says has a 24-inch diameter. If both pizzas are the same thickness and the same price, we want to figure out which option is going to give us the most pizza for our money. So we're going to need a couple of formulas here. We're going to be using area formulas. So first let's look at a rectangle. So for a rectangle, in order to find the area, what we do is we take the length times the width of our rectangle. So looking at the information that we're given, we've got the 18 inches and the 24 inches as our length and our width. So if we multiply those together, 18 times 24, we're going to get about 432 square inches of pizza in that rectangular pizza. Now, if we look at our circular pizza, the area formula for a circle is pi r squared. Now, we were told that the diameter is 24 inches. Remember, radius is half of the diameter. So the radius of our pizza is going to be 12 inches. So we're going to have to take 12 and square it in this formula in here. So 12 squared is 144. So we've got 144 times pi, which if we multiply that out on our calculator, that's about 452.4 square inches. So if we're comparing these pizzas, the circular pizza gives us 20 square inches more pizza for our money. So if we're looking at the same price for each one of these pizzas, we're getting more for our money with that circular pizza. Now here we're going to look at designing an algebraic model. So it says that a department store is having a sale and everything is discounted 25% off of the marked price. Okay, so they're going to take the discount at the counter, but then there's taxes on top of that. So there's a 6.5% state sales tax and there's a 0.5% local sales tax. So the first thing we're looking at is that the discounted price, which we're going to call D, is related to the marked price, which we're calling M, and they're related to each other by the formula D equals K times M. And K is going to be some constant, and what we want to do is figure out what K is. So we're looking at relating the discounted price to the marked price. And it says in the setup for our problem that everything is discounted by 25%. So that K value is actually going to be the percentage that we're actually paying. So if we're taking 25% off, then we're actually paying 75% of the actual price. Now, as we're looking at this model, we don't want to use the 75%. We're going to take that and convert it into a decimal. So we're going to be dealing with a K value of 0.75. So we could actually take this formula and rewrite it using that K value. So the discounted price is equal to 0.75 of the marked price. Now, taking things a little bit further, this says that the actual sale price is related to the discounted price using the formula S equals D plus TD, and T is going to represent some constant related to the total sales tax. We want to figure out what our T value is. Now, it says in our problem that we've got a state sales tax of 6.5%, and we've got a local sales tax of 0.5%. So as far as the total percentage, if we just add those together, we've got 7% worth of tax. Now, just like we did on the last one, we don't want to deal with the percent. We want to take that and turn it into a decimal. So if we slide the decimal over a little bit, then our taxed amount is 0.07. So if we take that and plug that into our formula up here, we're going to get S equals D plus 0.07 D. Now these D's are actually like terms, so we can add them together. In front of this first D, there's no number written in there, so we should read that as an implied 1. And if we take 1D plus the 0.07 D, we're going to end up with the formula S equals 1.07 D. We're going to keep going with this here. So this says we can use the answers from step 1 and step 2 to help us find another constant P, which is going to relate S, which is the actual sale price, including tax and all that, directly to M, which is the original marked price of our item, using the formula S equals P times M. And we want to figure out what P is. So going back to step 1, we came up with the formula that says the discounted price was 0.75 times the marked price. And then in step 2, we came up with a formula that said the actual sale price was equal to 1.07 times the discounted price. So we're actually going to take these two separate formulas and combine them, doing a little substitution. So we know that D is equal to this 0.75 M. So what I'm going to do with this is I'm going to take this 0.75 M and I'm going to plug it into my next formula over for that D value. So when we do that, we get S equals 1.07. Now remember, we're getting rid of the D in here and we're replacing it with what we know D is equal to, which is 0.75 M. Now a little bit of multiplication in here. We have to take the 1.07 times the 0.75, and when we do that, we get 0.8025 M. So our p-value is that 0.8025. So now here's where all of this is going to come together. Step 4 says that you've got $30 with you. We want to figure out if you can afford to buy a shirt that's marked $36.99. So we're going to use our most recent formula that we came up to, which said that the actual sale price, the cost that you're going to pay, is 0.8025 of the marked price. Well, here we've got a marked price of $36.99. So we're going to take that and plug that in for our M value. So we're going to get S equals 0.8025 times our $36.99. And if we go ahead and multiply those together, doing a little rounding, we're going to get 29.68. So the actual purchase price, including tax and all that, is going to be $29.68. You've got $30, so yes, you can afford to buy this shirt. One more here. So let's say you're at the store and you want to spend no more than $100. We want to figure out what the maximum total value of your marked purchases is before the discount is taken. So we're going to use that exact same formula, that S equals 0.8025 M, but we don't want to spend more than $100. So that's actually going to represent an S value. That's what we want our actual sale price to be. So we're going to take that 100 and plug it in on the left-hand side for our S. And what we're trying to do is figure out the marked price. So we're trying to solve for M here. In order to get M all by itself, we're going to have to divide that 0.8025 over to the other side. And when we do that, taking the 100 divided by the 0.8025, we get about 124.61 as our M value. So all of our items, as far as their marked price go, can add up to $124.61, but we're still going to be able to afford that for $100 or less. That's going to be it for this video. Thanks for watching.